Every day, thousands of malware files bypass traditional antivirus. Zero-day threats, polymorphic malware, file extension spoofing attacks. They all share one weakness. They can't hide from behavior. Introducing ZeroRisk Sentinel, the next-generation security scanner that combines static analysis, sandbox execution, and AI-powered threat intelligence to detect what others miss. I'm going to show you every capability in the next 10 minutes. Let's dive in. ZeroRisk Sentinel's core strength lies in what I call its threat detection arsenal. This platform is not built on a single detection technique, but on a layered security architecture combining static inspection, sandbox execution, and AI-powered threat intelligence. The first capability, deep file analysis, performs YARA rule scanning to detect known malware families, calculates entropy to identify packed or obfuscated binaries, and generates cryptographic hashes, such as SHA-256, for threat intelligence lookups through VirusTotal. This ensures strong static inspection before execution. The second capability, Hybrid Sandbox, executes files inside an isolated environment to monitor real-time behavior, such as process injection, network activity, and MITRE ATT and CK technique mapping, allowing detection of threats that evade static scans. The third capability, URL Deep Scan, uses browser sandbox analysis to capture screenshots, monitor network behavior, and detect phishing patterns or brand impersonation attempts through URL-scan integration. Moving further, the APK inspector analyzes Android applications by extracting permissions and identifying dangerous combinations that may indicate surveillance, privilege escalation, or persistence mechanisms. The AI Threat Intelligence module leverages a Grok-powered large language model to convert raw technical findings into structured, analyst-style explanations, helping users understand not just what was detected, but why it matters. Finally, the multi-source intelligence layer aggregates data from Google Safe Browsing, URL House, VirusTotal, SSL certificate inspection, and DNS analysis, combining over 70 threat intelligence signals into a unified risk score. Together, these modules create a hybrid detection system capable of analyzing files, URLs, and APKs with both static and behavioral depth, delivering enterprise-level security insight in a unified interface. ZeroRisk Sentinel doesn't just scan files. It validates their integrity. The File Integrity module checks whether a file has been tampered with by analyzing its structure, verifying hash signatures, detecting corruption, and reviewing modification timestamps. This helps identify manipulated or repacked files before execution. The extension spoofing detection engine protects against social engineering attacks. For example, a file like invoice.pdf.exe may look like a document, but it's actually an executable. The system compares the real binary signature against the file extension and immediately flags mismatches to prevent disguised malware from being opened. The Permission Risk Assessment module evaluates access levels required by a file or application. It differentiates between standard permissions and high-risk capabilities, such as administrative privileges, system access, registry modification, or network communication. This allows the platform to assign contextual risk before runtime behavior even begins. In addition, the Live Analysis console provides real-time visibility into the scanning pipeline. It displays rule matches, entropy calculations, hash generation, and threat intelligence lookups, giving full transparency into how the final threat score is calculated. Alright, so before running a live sample, I'll quickly open the info section here. This deep scan feature allows files to be executed inside an isolated sandbox environment. Instead of just checking signatures or static patterns, the system actually observes runtime behavior, like process spawning, network connections, and potential MITRE ATT and CK techniques. This means even if malware is heavily obfuscated and bypasses static checks, its behavior will still expose it during execution. Now, I'll switch to demo mode. Demo mode provides safe, pre-built threat samples specifically designed to simulate real-world attack patterns without any actual risk to the system. I'm going to download the Keylogger demo sample. Keyloggers are commonly used for credential harvesting. They monitor keyboard input and silently capture sensitive data, like passwords and OTPs. Now, I'll enable Deep Scan to ensure both static analysis and sandbox execution are performed. Let's submit this file. And as you can see, the analysis completed quickly, and the file has been marked as critical. The threat score dynamically adjusted based on multiple detection layers, not just one indicator. The severity bars on the left update in real time, reflecting how different modules contributed to the final risk score. Scrolling briefly through the analysis console, you can see the backend processing pipeline in action. This ensures the decision is transparent and technically explainable. Now, let's move to the results page for a more detailed breakdown of the findings. Now, on the results dashboard, you can see the overall threat score visualized through the security gauge, giving an immediate snapshot of risk severity. The threat proximity map shows how closely this sample aligns with known malicious behavior patterns. These visuals are generated from combined static analysis, sandbox behavior, and threat intelligence signals, all merged into one unified score. Now looking deeper into the results, you can see exactly why the file was classified as critical. At the top, the system generates cryptographic hashes for integrity verification and threat intelligence correlation. The entropy score gives insight into whether the file may be packed or obfuscated. In the hybrid analysis sandbox section, we can see runtime behavior indicators, including process creation and files dropped during execution, which are strong signs of malicious activity. The MITRE ATT and CK mappings show how the behavior aligns with known adversary techniques, such as credential dumping, system discovery, and privilege-related actions. This confirms that the detection is behavior-driven, not just signature-based. The findings section lists multiple YARA rule matches related to keylogging and exfiltration patterns, strengthening static detection confidence. Finally, the AI-assisted threat explanation summarizes the most critical indicators in a structured, analyst-style format. Instead of overwhelming users with raw technical logs, it explains what was detected, why it matters, and what the file appears capable of. For non-technical users, this makes the results easier to understand, translating complex malware behavior into clear risk insights. It bridges the gap between deep technical analysis and practical decision-making. Now I'll run the same keylogger sample again, but this time without enabling deep scan. This means the system will perform only static analysis, including hash generation, YARA rule matching, entropy calculation, and threat intelligence lookups, but without sandbox execution. Let's submit it. This time without deep scan enabled. The analysis completes instantly using static inspection only. You can briefly see the analysis console updating, showing hash generation, rule matching, and entropy evaluation in real time. Now, jumping to the results view. Even without sandbox execution, the file is still classified as critical. This is because multiple high-confidence YARA rules related to keylogging were matched during static analysis. However, compared to the deep scan version, we don't see runtime behavior indicators like process activity or drop files. This highlights the layered design of ZeroRisk Sentinel. Quick scan delivers fast and effective static detection, while deep scan adds behavioral depth when needed. Now, I'll move to APK analysis. Here I'm submitting an Android application package for inspection. The system begins by extracting metadata, permissions, activities, services, and receivers from the manifest file. Within a few seconds, the APK is flagged as a threat. Scrolling down into the real-time analysis section, we can see how the system evaluates requested permissions and identifies risky combinations. The console briefly shows the internal processing, permission analysis, risk scoring, and threat correlation happening in sequence. Now jumping to the detailed results view. Now looking at the APK results, the application has been classified as critical with a full risk score of 100. At the top, we see the file hashes and an entropy value close to 8, which suggests the APK may be packed or obfuscated, a common technique used to hide malicious logic. In the security findings section, the system detects suspicious native code usage, obfuscation indicators, and ransomware-like patterns. The dangerous permission section is especially important. Permissions like System Alert Window can enable overlay attacks. Bind Accessibility Service can monitor user interaction across apps. And Receive Boot Completed allows the app to automatically start after device reboot. When these are combined, they strongly suggest surveillance or credential harvesting capability. For non-technical users, this simply means the app is requesting powerful system-level access that normal applications typically do not need. And just like with file analysis, the platform also provides an AI-assisted explanation. Instead of just showing technical flags, it translates the findings into clear, understandable risk insights, helping both security professionals and everyday users understand what the app might actually be capable of. This shows that ZeroRisk Sentinel is not just a scanner, It's an interpretable security analysis platform. Now moving to the URL analysis module. Before running a live scan, I'll briefly open the information section. This module analyzes URLs using multiple intelligence sources and behavioral signals. It doesn't just check whether a link exists. It evaluates domain reputation, SSL configuration, DNS records, redirect chains, and threat intelligence databases, such as Google Safe Browsing, URL House, and VirusTotal. For deeper inspection, the system also supports URL sandbox analysis, which loads the link in an isolated browser environment to monitor real-time behavior, such as network activity, redirection patterns, and potential phishing indicators. This ensures that both static domain intelligence and behavioral analysis are covered. Now, let's test it with a live example. Now I'll switch to demo mode and scan a well-known, legitimate website. Submitting the scan. The system evaluates the URL using multiple intelligence sources, including domain analysis, SSL validation, DNS inspection, and threat intelligence lookups. The analysis completes and redirects us to the results dashboard. Now looking at the results for Stack Overflow, the system classifies the URL as safe, with a threat score of 0 out of 100. In the Sandbox analysis section, we can see the browser simulation results generated by the isolated scanning environment. The system records total requests made during page load, the number of unique domains contacted, and the SSL certificates observed during the session. In this case, there are 0 suspicious domains detected, which is consistent with a legitimate production website. The console logs show several 403 status responses. These are not errors from our system. A 403 status simply means forbidden, which occurs when a server blocks automated or headless browser requests. Many major platforms use bot detection, rate limiting, or web application firewall protections to restrict non-human traffic. This behavior is expected when performing sandbox-based URL analysis and does not indicate malicious activity. Looking at the server info section, we can see the resolved IP address, hosting country, and server provider. In this case, Cloudflare. This confirms the domain is backed by a reputable content delivery and security infrastructure. Moving further down, the threat intelligence section confirms that Google Safe Browsing marks the domain as safe. URL House does not list it as malicious, and VirusTotal reports 0 detections across security vendors. The SSL certificate is valid. There are no suspicious redirects, and no malicious indicators were detected. This demonstrates that ZeroRisk Sentinel does not generate false positives. It correctly identifies legitimate, high-traffic platforms as safe while still performing full technical analysis behind the scenes. And that concludes the demonstration of ZeroRisk Sentinel. Throughout this walkthrough, we've seen how the platform analyzes files, Android applications, and URLs using a layered security architecture. From static inspection with YARA rule matching and entropy analysis, to behavioral sandbox execution, MITRE ATT and CK mapping, and multi-source threat intelligence aggregation. The system combines multiple detection techniques into a unified risk scoring model. We've also demonstrated how ZeroRisk Sentinel avoids false positives by correctly identifying legitimate platforms as safe, while accurately detecting malicious samples, such as keyloggers and high-risk APKs. Beyond raw detection, the platform emphasizes explainability. With real-time analysis logs and AI-assisted threat explanations, it translates complex security findings into structured, understandable insights, making it valuable not only for cybersecurity professionals, but also for developers and general users. ZeroRisk Sentinel is designed to bridge the gap between lightweight scanners and enterprise-grade security analysis platforms, delivering interpretable hybrid threat detection in a single unified interface. Thank you for watching.